Hello everyone, welcome to Better Tech. So today we have Matt Butcher with us. Hello Matt, how are you today?
I'm great. Thanks for having me.
All right. So Matt, again, thanks for joining us for this great podcast. So why don't you go ahead, Matt, and tell us a bit about yourself?
Okay. All right. So I'm Matt Butcher. I have been in the industry since I was actually in high school. I sort of accidentally got a job in computer programming and really enjoyed it. For the first part of my career, very interested in content management systems, but then, about a decade ago or so, sort of stumbled into the world of cloud computing and got so excited and have just been fully sort of ingrained in this community ever since. Worked on virtual machine technologies, and then after that, container technologies and Kubernetes. And these days, about a year ago, we started a company called Fermyon. And Fermyon is really interested in WebAssembly on the cloud side, because we kind of think it's the next wave of cloud computing, the thing that's going to sit alongside virtual machines and containers to enable a whole bunch of new kinds of compute workloads.
So you talk about that you have been into technology since early days of your life. So how do you define the journey had been, and if today, based on the experience that you have, what you could have done differently if you were given a chance again?
So when I first got started, I got started in must have been like 1995, I guess. I was playing with a beta version of Windows 95 when I first got started. And I think that one of the things, I was very fortunate to have mentors in my life at that point who came alongside me and really kind of not just taught me how to do something, but taught me how to learn things on my own. In that sense, I think because of that kind of combination of my own passion and somebody saying, here's how you teach yourself, here's how you learn things, here's how you follow your interests. I feel like I was very, very fortunate in the way I got to learn that kind of thing. So in that sense, in the very earliest days, I wouldn't change anything. And often in my career, as I've, run across people that are interested in the field, I've found that kind of mentorship pattern to be useful. I think one of the other things I kind of learned that actually I wouldn't change, but that at the time I thought I would want to change, was that I spent a lot of time working on very high level applications. I always thought of myself as kind of a system programmer kind of person, but spent, years doing SEO kinds of work and web development work and PHP development. And at the time, I sort of struggled with feeling like I wasn't doing, quote unquote, real computing, because in my mind, systems computing was the real thing and web development was just sort of a thing people do.
Yeah.
But, in hindsight, I learned so much from doing that kind of development, and really nothing more than learning empathy with the people who use your applications, particularly when you're doing website design and things like that. The people might not even be tremendously technical. And I think one of the most valuable lessons that came out of that for me was I had for a long time considered engineering to be largely what I would call hyper rational, right? We're logic processing machines, right? We're capable of all of this focus on figuring out how things work. But one of the things that particular industry really opened my eyes to is the fact that, at the end of the day, we're all emotional creatures, right? And we're all motivated in similar ways. And when you start to understand your peers and your audience and other developers in that way and build up empathy that way, that's big, right? It enables you to kind of reach people in a way that makes them feel included and makes them feel fulfilled. And that's profound.
Mm-hmm. Yeah, that's great. And also, you must have faced a lot of challenges in your journey. So can you talk about a few, and what would you rate as the most challenging challenge?
Okay. So background for me, I did not study computer science in university. I studied philosophy. I actually have a PhD in philosophy, much to my parents' chagrin, right? I'm sure every parent is like, go be a lawyer or a doctor, and I chose philosopher. And because of that, my approach to programming was always kind of different from other people's, right? I didn't have a strong basis in algorithms, for example. I've written probably a grand total of about 6 lines of assembly ever in my life. I just didn't have the same academic grounding there, but I had a strong academic grounding. And I think one of the things you learn from philosophy that is certainly not unique to philosophy, but is definitely a thing that you can't be successful in philosophy without learning, is how to think in terms of systems, right? How do you read a philosopher, whether it be, ancient Greek philosopher or an Arab philosopher or an Eastern, Chinese philosopher, any of these kinds of systems, right? Every one of them is trying to articulate a system and trying to articulate how they view the world and how the pieces fit together in their mind, so that they can try and, come out of that and say, okay, so this is, we should consider this as a way the world might work. And we should consider these as the way we should learn things in the world and how we should understand knowledge and things like that. But in order to be a successful philosopher, you have to be able to do 2 things, really. You have to be able to read that and be deeply sympathetic to the author and understand how they were thinking about a system and how they were articulating a system. And also, as you start practicing philosophy yourself, you have to be able to articulate a system and think in terms of not just the one thing you're solving here, but how it would fit to all the other pieces of your philosophy, right? That is a very useful way of approaching software development. And I like to talk about it as being able to zoom into the details of something and then zoom back out and see the whole system, your whole application, and then zoom back in over here and say, okay, how am I going to do this sorting algorithm while in the context of, this whole bigger application? It helps you do things like say, okay, I'm spending too much time working on the details of this, or I'm not spending enough time working on this other part over here. So it helps on project management, but it also helps a lot on design. Now, where that has come to haunt me over time and how it has proven to be sort of a challenge to me is that one of the things that software developers and maybe philosophically minded ones in particular, we can really, what I would call rabbit holing, right? Get really focused on something and just kind of get narrower and narrower into it and try and solve this problem and try and solve this problem to the point where we lose sight of the big picture altogether. And it's sort of like, in that ability of a philosopher to go high and low and high and low, sometimes we get so obsessed with wanting to make sure that we're really right about this one thing, that we've really thought it through, we worked through the syllogisms. That tendency in software development led to me getting sort of like into this paralysis mode where I would write code and write code and write code. And before long was so focused on solving those problems that I had lost sight of the big goal. That was something I ended up having to train myself out of. And it was really by going back to how philosophy works that helped me train my engineering brain to stop doing that.
Right. So essentially, I mean, a lot lesser abstraction, rather focusing on getting things done, one problem at a time. I mean, attacking it with full force and then getting it done.
Yeah. And that kind of, we use the term pragmatism fairly loosely a lot of times, but in this case, that is what it is, right? Making sure that you're keeping track of what your actual goals are and not letting, a very technical problem distract me from solving the actual goals. Yeah.
So what is your startup name? How does the name come up and what does it mean?
Right. So we started a company called Fermyon in November, and it's Fermyon, but it's actually a play on words on the subatomic particle a fermion, which was named after Fermi, the physicist. So a fermion is one of the smallest particles, and they tend to group together and compose the matter that's around us in the universe. And the reason we chose this really has to do with the technology that we're developing. We're building a WebAssembly platform for the cloud, and we wanted to articulate in our name that to us, the way that you build this kind of next wave of cloud computing is by taking small little functions and things like that and piecing them together to build bigger composite applications. And from a distance, you tend to look at the application as a whole, but when you look up close, you see that it's composed of a number of small pieces.
So, I mean, you touched upon cloud computing. If you would have to really explain to someone in layman terms what cloud computing really is, I mean, how would you do that?
I can explain very clearly how I started to understand it, and hopefully that would be helpful to a lot of people.
Yeah, I'm asking this question because you have like a a philosophy background, so maybe you can explain that, keeping that context in mind.
Yeah. For me, sort of the watershed moment for me was I always thought of the relationship of a hardware and an operating system as kind of a one-to-one thing. You have one piece of hardware, it's running one operating system. In the era that I grew up in, that was definitely the case, right? And when I started looking at cloud the first time, when I first came into contact with the core ideas of it, the first helpful piece was to say, oh, okay. So where I used to have a one-to-one relationship, hardware to software, now I have a one-to-many relationship, a piece of hardware to many different operating systems. And then when you start thinking about virtual machines as sort of like not necessarily linked directly to the hardware, but sitting one layer above, then you can start thinking about them as things that you can move. And that to me was the sort of aha moment. Oh, well, if I can run the same thing here, package it up and then ship it off somewhere else and start it up again and be running the same operating system, but on different hardware, that's a big change. And that to me was when cloud computing started to click. Oh, I can take my operating system, package it up and run it on somebody else's hardware and pay them to maintain that hardware. And I get all the benefits that I would have had if I had it here, plus, some others as far as different services go. And then when you start looking at virtual machines, containers, and then this kind of blank space that we're filling in, virtual machines are like the heavyweight class, right? You think of it as like the workhorse of the cloud, from the kernel and the drivers and the file system and all the libraries and utilities, all the way up to my application code. It's one big bundle. Yeah. But then when you look at a container, right? A container is just a smaller version, sort of like the middleweight version of cloud computing. It doesn't have the kernel and it doesn't have the drivers. Those are supplied for us. Yeah. So you just take that little thin slice of the file system and utilities, you put your application on top, and then you've got this smaller one. And that was actually how we ended up at Fermyon. We looked at that and went, okay, so there's a big giant heavyweight one and there's a middleweight one. Is there a little lightweight one that maybe is just the application and the bare minimum number of supporting files it needs, and doesn't have the file system and the file system, the operating system utilities or the kernel or any of that? And that was kind of what led us toward WebAssembly. So for me, cloud computing in general is like, how do we take the stuff that we care about executing and we push it out somewhere else, let somebody else do it for us? And it turns out there are some distinct flavors inside of that.
So while explaining, you also touch upon WebAssembly. So how would you explain WebAssembly as well?
So, and I'm always going to lapse into philosophy kinds of things. The interesting thing about many technologies is we build them for one purpose. And then we discover as we build them, oh, look, this is something I could use over here and I could use it over here. WebAssembly is one of those technologies. So the original idea behind WebAssembly was, JavaScript has done amazing stuff for us in the web browser. But a lot of us tried different languages, Python, Ruby, Rust, Go, all these different languages that we like. It would be really cool if we could use those languages inside the browser too. So WebAssembly was conceived of originally as a compile target where I could compile Rust to this WebAssembly format and run it side by side with my JavaScript in the browser. And that's really all it was. If you look at Figma or Adobe or some of those big graphics ones, they get a lot of performance advantage out of taking C++ or Rust and compiling it to WebAssembly and running it in the browser. But it turns out that technology can be used in a whole bunch of different places. Like because of the way it's written, you can execute a WebAssembly binary inside of an IoT device, a tiny little IoT device, or you can use it as a plugin model like the Envoy proxy does and allow developers to write their own stuff in whatever language they want that augments your core application. Or in our case, cloud computing was really interesting. The security model of WebAssembly made it a really good kind of cloud technology. So it's a great example of a technology that was built to solve this problem. And because it was done so well, it turned out that the problem space it could solve was much wider and much broader than just something in the browser, but something that we could do in embedded devices, cloud, edge, all kinds of different areas.
Sure. So, since WebAssembly is like, you can say, a smaller component, independent component, which can be deployed on the cloud, as you said, how you have found the performance of it to be?
So one of the most exciting things about WebAssembly is its performance. It was built to run in a browser, and as we all know, as web users, right, we don't like waiting for things in the browser.
Yeah,
So WebAssembly had to be very fast and had to start up very quickly. So if you look at the startup speed of a virtual machine, which is the heavyweight class again, it tends to take a couple of minutes to start up.
Yeah, spin off, yeah.
Yeah, and if you move over to containers, well, they're much lighter weight, but they still take maybe 2 seconds to start up. So what we were hoping to find in the lightweight class was something that could start up nearly instantly. And WebAssembly very, very much fit that bill. We were originally shooting for under 100 milliseconds. We've managed to get it really down to under 1 millisecond to get it started. So they start up and execute very, very quickly, which makes them a great kind of compute platform to run those things where you really don't want to be running them all the time. But when you do need them, you need them to be very, very fast to start up, do their job, and then shut back down again. And that's why we kind of talk about it as a third class of computing, right? It's doesn't necessarily compete directly with containers or with virtual machines. It's complementary to those other two technologies. And we feel like kind of helps fill out the landscape to be able to run lots of different kinds of compute workloads in the cloud.
So for example, if someone, developed a WebAssembly, how does it get deployed to the cloud using your particular tool set, and how it becomes available to the global user base? What's the process, how it works?
And we really wanted to make that story very easy, right? We wanted to make it as simple as possible for a new developer to get started with WebAssembly in the cloud. Our kind of core guiding story for the last year has been, as a developer, you should be able to go from a blinking cursor to a deployed application in 2 minutes or less. So we have two pieces to that. One is this tool called Spin. If you've used Docker before and you're used to building Docker images, Spin is sort of like the Docker thing for WebAssembly. So you start a new project in the language of your choice. You can compile it. You start it with Spin new, compile it with Spin build, and then when you're ready to try it out, you just type Spin deploy, and it'll push it out to the second part, the second thing we built, which is called Fermyon Cloud. Fermyon Cloud is just a free hosted runtime in the cloud that you can deploy an application and try it out and see how it runs. And it's show it to your friends. It has a public available IP address. So it's basically like you are running it in our cloud. And over time, Spin or Fermyon Cloud right now is very early. We did an open beta of it. So you're invited. Okay. If you got a GitHub handle, it's really easy for you to get started. But over time, we'll keep adding more and more features, database backends and things like that, that'll make it easier and easier for you to build big applications in WebAssembly and get all these performance benefits and all these, bring your own language runtime kinds of benefits as well. So we're really excited about the next year as we roll out new kinds of storage and higher
new features.
Yeah.
All right. So, your product, as you explained, sounds like highly technical in nature. And it must be like a very competent team of developers, engineers, architects who actually, made that happen. So how did you build that dream team, and how did they, bought into the idea of yours?
I don't like bragging much, but I do like bragging about our team. We, a bunch of us work together on container technologies, many of us at Microsoft, even on the same team. And so there's a sense in which a big group of us had already worked together and worked in some really interesting emerging technology fields like Kubernetes. And we kind of all jumped in at the same time. So 10 of us started at Fermyon on the exact same day, the first day of the company. And we already had worked together. So a lot of that kind of early period where you're trying to get to know the team and figure out a workflow, we had a lot of that to start with. But then from there, we've been able to continue building up a just absolutely stellar team of engineers from all over the place, from small companies to big other, Google and other places like that. We've found engineers that came alongside us and said, yeah, we want to work together doing this kind of thing. We do a lot of work on hiring with values in mind and with, workplace culture in mind. And that has helped us a lot. It's hard to be a fully distributed team like ours and still keep communication up, particularly when, like us, you're spread across 5 continents, even though there are only 25 of us. And so we've relied a lot on things like Slack and asynchronous communications and
Sure.
have stand-ups early, and what's early in my morning, so they're Europe friendly, and late in my evening so that they're Asia and Australia friendly. And by doing things like that, you can really draw the best developers from all around the world and have them work on the same team. That has been just really exciting.
So, exactly explains like how and the team has been like working together. But since the very beginning, I mean, you said you were 10 people who started working on the project. So how did you keep the team motivated? I mean, and as things go, there are a lot of conflicts related to tech stuff or maybe business stuff as well. So how did you manage to scale as well as keep the operations going while keeping those conflicts intact?
Yeah. And the interesting thing about being early in a technology field is that there's a sense in which you're having to define the boundaries of the problem space while you're trying to solve the problem, right? So it's almost on one sense is a little more stressful, and in another sense there's more possibility. And so what we did to kind of get ourselves all aligned on a common goal was the day we started the company, we said, okay, the first thing we want to do is be able to run our own website on our technology. So that means we need to build a stack that we want to be users of, and it needs to do X, Y, and Z. So it gave us, took us from a very broad problem space down to one very specific problem we needed to solve. And immediately that galvanizes the engineering team to start working together because they've got a goal in mind. It's a concrete goal. It's a goal with a timeline, and it's a goal that for us as a company makes a big difference because we're going to use the technology. And that helped a lot. Conflict is always going to arise, right? And we knew early on that we wanted to do a good job at handling conflict, because it can be very healthy to have different opinions and then to go through the process of articulating your viewpoint and arriving at an educated goal. But it can be very unhealthy if along the way people's feelings are getting hurt or there's backroom controversy around things. So early on, we actually contracted with a psychologist, an organizational psychologist, who came in and gave us training sessions on how to handle conflict, how to avoid, that kind of backroom back chatter that's destructive, how to make decisions well as a team. And we started off with him just doing it, once a month kind of lunch and learn kinds of things where we all ate some food and listened to him talk. And over time, we've gotten to the point where he comes in and helps us with interviews. He comes and facilitates leadership team meetings and all kinds of things, because we found the value of having someone dedicated to helping us work through those has been just extraordinary. And I think gives us a big advantage as a startup when a little bit of argument could really stall us out on getting things done. So having somebody there who can basically stop a conflict as it's going and going, okay, people are getting a little heated here. Let's just figure out what the actual problem is and we'll figure out how to address it. And then we'll move on. It's been phenomenal to have someone like that.
So what does like the 5-year, 10-year vision looks like?
So for us, we really like we really set out to build a cloud platform that we could run. We think that WebAssembly is really promising, and it is the most promising when we can get into the situation where we can host hundreds of thousands of applications from tens of thousands of different organizations, and if we can host those, then we can really optimize the platform and drive the cost way down. And I think with the economy taking a little bit of a downturn, it is about time that we all start asking, how can we make cloud cheaper? How can we cut the cost of renting somebody else's server? So that's really exciting to us. So our 5-year plan right now really is to continue building that out. And we want to, because it is cheap enough for us to operate, we want to make sure that individuals who are getting started in this technology always have a free place to start up and build their own applications and run their own blogs and websites and things like that. But then as we go, we'll start adding paid tiers for things like for teams that are working together and get a lot of value out of our platform and are going to be driving higher traffic. And then eventually someday, a big enterprise tier for the places that really care about things like auditability, single sign-on, regulatory compliance. So that's our plan really going forward, build a platform.
You touched upon the economics and recession topic. So what would you recommend to startups out there to keep themselves going, and how do you see recession, affecting businesses?
Yeah, and I can pass on advice I've heard from a number of trusted advisors, because I am not the expert on this, but I love hearing from people who are. And the advice that I have heard from them is, first of all, be mindful of how much money you have in the bank, right? And how long you can run. Because of course you don't want to burn through that too early. But also pay attention to the fact that for a small startup, this is a time that actually works to our advantage, because the larger corporations have already started scaling back, things like advertising or, showing up at conferences by the dozens, right? The things that tend to give them an advantage when they're promoting their message. And so, it's an opportunity for us to be able to be a little bit, louder in the marketplace of ideas. So we have focused a little more on, doing things like video production, where we can do our own videos and then send out tweets and things like that. Because right now, there aren't as many large corporations doing that kind of thing. So that one I've really taken to heart. Visiting conferences is another, as the conference season kind of picks up, particularly, local ones and meetups and things like that. There's a big opportunity now for us to be able to make good, strong one-on-one connections with other people in the community. And those are the people we care about, right? We're a developer-oriented company. So we care a lot about finding developers and knowing that we're meeting their needs. And there's a big opportunity right now for a small startup to be able to do that without just feeling constantly overwhelmed by, the Amazons and Googles and Microsofts of the world.
So, I mean, in the end, what sort of message you would like to give to the startup community listening to you, and what's your advice for them?
Yeah, I think two things really, right? Right now, it's easy to let anxiety sort of weigh in, right? Or anxiety to sort of gnaw at you. There's a lot of uncertainty in the world, but optimistic perspective on what's going on right now. That's something we should really take to heart. Things will be a little bit easier for us for a couple of years because of that missing pressure. The second one is, the kind of post in the aftermath of COVID, which was horrible and difficult on all of us. The shape of the way we interact with each other has changed a little bit. We can talk, we understand now how to talk to people on the other side of the world much more effectively because we're comfortable using technologies like Zoom, and we're not quite as focused on in-person connections. And that too is a thing that I think we as startups can really take advantage of, both in terms of things like hiring, like you and I talked about a moment ago, but also in terms of just, reaching out to people on the other side of the world and saying, hey, we're really excited about this. We see you're excited about it too. There's no reason why a little bit of distance should get in the way of us at this point. And that to me is a really exciting change that's happened in the last 2 years, that for a startup, that's big, because we don't have the budgets to fly to Africa or to Australia to be able to meet people one-on-one. But, a Zoom call is a fantastic opportunity to make a connection with someone.
Yeah.
So two things that I think are definitely, as a startup right now, we can seize the moment and take advantage of those.
So Matt, thank you once again for your time today to be with us on Better Tech and enlightening us with your vision and thoughts. So I hope to host you sometime soon regarding like a more in-depth session related to cloud and WebAssembly. And once again, thanks for being with us.
Sure. Thanks so much for having me. This was a lot of fun.
Thanks. Bye.